Okay, good day. So again, this is Engineer Ernesto Ciclodensiado Jr. and welcome to my channel. So we are going to continue with our subject integral calculus, and we are now in inverse trigonometric function. Okay, so in inverse trigonometric function, we are given these two formulas. Actually, there are more formulas aside from these two givens, but this is the most common formulas. So I will focus the discussion only on this. Okay, so let's jump to the example. Okay, so this is the example number 1. Integral of dy over 9y squared plus 6y plus 5. Okay, by inspection, we can say that the formula to be used is formula number 2 because of the absence of the radical sign in the denominator. So this is the arctan. So first, we must transform the denominator into binomial equation. So recall in your algebra, the binomial theorem. Initially, the denominator is not in the form of a perfect square, so we cannot transform this into binomial equation. So we must find ways for us to transform this. Okay, so all I have to do is, I will inspect if what should be the constant that would transform this into perfect square. So if I have 9y squared plus 6y, so what should be the constant here for this to be a perfect square? Let's try 1, okay? So therefore, this becomes what? 3y plus 1 square. So that if we apply the theorem of binomial, this will be square the first term, so 9y squared, twice the first and the second term, 6y, and square the last term. This is 1. So therefore, this is now in the perfect square. Okay? So the equation is 3y plus 1. Okay? So therefore, this will be 6y plus 1. But we have 5 here, so therefore, the remaining is 4. So that 1 plus 4 equals 5. Okay? And this part now is a perfect square. Okay, so simplify further. This becomes 3y minus 1, plus 1 square plus square root of 4 is 2, so therefore 2 squared, that is equals to 4. Okay? Okay, so if I may interchange that, this is 2 square plus 3y plus 1 square. Okay? So this is now in the form of our formula number 2. Okay? So what is our a? That would be 2. Our u is 3y plus 1. Our du is equals to 3 dy. Therefore, dy equals du over 3. Okay? So we must substitute now the value of u and du to our original equation. So therefore, dy equals du over 3 over a squared plus u squared. Okay? So factoring out 3, so this becomes 1/3 integral of du over a squared plus u squared. So this is now the equation that is applicable to our integration formula. So this becomes 1/3 1 over a arc tan u over a plus c. So substituting that, this becomes 1/3 1 over a, and a is 2. Arc tan u is 3y plus 1 over a is 2 plus c. Okay? So further, this becomes 1 over 6 arc tan 3y plus 1 over 2 plus c. So this is now our final answer. So by the way, class, no, for you to be able to decide right away which of the formula 1 or 2 will be used, so this is my technique, no, during my time in college. So if arctan, meaning tanggal, so wala siyang square root, okay? Or wala siyang radical sign kasi arc tanggal, okay? Okay, so the arc sign, kasi hindi siya tanggal eh. So mayroon siyang square root. So that's for me, no? That's my method to memorize this formula. It's up to you if you will adopt my method, and or you can also do in your own understanding. So as long as you memorize these two common formulas for inverse trigonometric function. Okay, so example number 2. Evaluate integral of dx over square root of 9 minus 4x squared. So by inspection, we can say that the formula to be used is formula number 1 because of the presence of radical. So recalling formula number 1, that would be integral du over square root a squared minus u squared. So that would be equal to arc sine because of the presence of radical. So arc sine u over a plus c. Okay? So determining our a, so a would be 3 because if you square that, that would be equal to 9. And u is equals to 2x. So if you square this, it will go back to 4x squared. So this one. Okay? So our du is equals to 2 dx. Therefore, dx would be du over 2. Okay? So substituting our value of u and du to our original equation, this will be du over 2 because this is the value of dx over square root a squared minus u squared. Okay? So therefore, we can factor out 2. So 1/2 integral of du over square root of a squared minus u squared. Okay? This will now be in the form of our formula here. So therefore, we can apply the formula for integration of this equation. So 1/2 the integral of du over square root of a squared minus u squared is equals to arc sine u over a plus c. Okay? Substituting our value of u and a by our original value, which is u is equals to 2x over a, that is equal to 3. Okay? Plus c. So further, final answer is 1/2 arc sine 2x over 3 plus c. So this is now our final answer. So let's go now to the example number 3. Evaluate integral of dt over square root of 5 minus 16 t squared. Okay? So by inspection, there is a radical sign. Therefore, this is not tanggal. So we will use the formula number 1, the arc sign. Okay? But first, we have to transform the denominator in order to be the same as the denominator in the formula. Okay? By the way, let's write the formula. So the formula is integral of du over square root of a squared minus u squared, and that would be equal to arc sine u over a plus c. Okay? So what is our a here? So a is equals to the square root of 5. Okay? and u here is 4 and 40. Okay, so that if you square this will become 5, and the u, if you square this becomes 16t squared. Okay, so let's substitute. By the way, du here is equals to 4 dt, and dt is equals to du over 4. Okay, so let's substitute our u and du. So integral of dt, what is dt? Du over 4. So square root of a squared minus 4t squared. Okay, so this is now the same as the denominator of our formula number 1. Okay, so in the form of a squared and u squared. So further simplification, we can factor out 4. So this becomes 1/4. Okay, integral of du over square root of a squared minus u squared. Okay, so therefore we can now use our formula for integration. So this will be 1/4 arc sine u over a plus c. Okay, so we will substitute the original value of u and a. So what is u? So that is this one, and a is square root of 5. Okay, so 40 over square root of 5 plus c. Okay, so therefore arc sine 40 over square root of 5 plus c, and this is now our final answer. Okay, so let's have an example that is not in our LP. So more challenging one. So this is now example number 4. Okay, so evaluate integral of dx over x squared minus 6x plus. Okay, so by inspection, we can right away say that the formula to be applied is formula number 2 because there's no radical. Okay, so arctan. Okay, so we're calling the formula of arctan. So integral of du over a squared plus u squared. So this will be equal to 1 over a arctan u over a plus c. Okay, this is our formula. Okay, so first we will transform the denominator of this equation to be the same as the formula given. Okay, we have to find a way that the denominator would transform into a binomial. So recall your binomial theorem, no? So to be this as a perfect square, we have to find a constant here that is equal to the perfect square. Okay, so to solve for the constant of the perfect square, we have to divide this 6 by 2 and square that. So if we divide 6 by 2, this becomes 3, and square that becomes 9. So therefore, we need a number 9 here to be able to transform this into perfect square. So, okay, I will write that x squared minus 6x plus 9. So this is now a perfect square. But we have 18. Therefore, we must put the remaining balance. So therefore, 9 plus 9 equals 18. So this form is now a perfect square. Therefore, I can rewrite this as x minus 3, okay, squared plus square root of 9 because we have to write the a squared. So therefore, this becomes 3 squared. So this is now transformed into equation that is the same to our formula given. Okay, so let's interchange, no? Okay, so our a here is equals to 3. Our u equals x minus 3. Therefore, du is equals to dx. Okay, so we must substitute u and du to the original equation. So dx would be equals to du, and 3 squared equals to a squared minus, plus x minus 3 squared equals to u squared. Okay, so this is now in the form of our formula. So therefore, this is equals to the integral of 1 over a arctan u over a plus c. Okay, so substituting back the value of a, 1 over what is a? 3 arctan, what is u? X minus 3 over a 3 plus c. So this is now our final answer. Okay, thanks for listening. Bye.